The SHEL model in human factors. It can be helpful to use a model to aid in the understanding of human factors, or as a framework around which human factors issues can be structured. A model which is often used is the SHEL model, a name derived from the initial letters of its components. Software, for example, maintenance procedures, maintenance manuals, checklist layout, and so on. Hardware such as tools, test equipment, the physical structure of aircraft, design of flight decks, positioning and operating sense of controls and instruments, etc. Environment, which includes the physical environment like conditions in the hangar, conditions on the line, and the work environment such as work patterns, management structures, public perception of the industry, and so forth. Liveware, meaning the person or people at the center of the model, including maintenance engineers, supervisors, planners, managers, and others. Human factors concentrate on the interfaces between the human, the L in the center box, and the other elements of the SHEL model. From a safety viewpoint, this is where these elements can be deficient. For example, software misinterpretation of procedures, badly written manuals, poorly designed checklists, untested or difficult to use computer software. Hardware, not enough tools, inappropriate equipment, poor aircraft design for maintainability. Environment, uncomfortable workplace, inadequate hangar space, extreme temperatures, excessive noise, poor lighting. Liveware, relationships with other people, shortage of manpower, lack of supervision, lack of support from managers. As will be covered in this document, man, the liveware, can perform a wide range of activities. Despite the fact that modern aircraft are now designed to embody the latest self-test and diagnostic routines that modern computing power can provide, one aspect of aviation maintenance has not changed. Maintenance tasks are still being done by human beings. However, man has limitations. Since liveware is at the center of the model, all other aspects, software, hardware, and environment, must be designed or adapted to assist his performance and respect his limitations. If these two aspects are ignored, the human, in this case the maintenance engineer, will not perform to the best of his abilities, may make errors, and may jeopardize safety. Aircraft are becoming more and more reliable. However, it is not possible to redesign the human being. We have to accept the fact that the human being is intrinsically unreliable. However, we can work around that unreliability by providing good training, procedures, tools, duplicate inspections, etc. We can also reduce the potential for error by improving aircraft design such that, for example, it is physically impossible to reconnect something the wrong way.